chosen one is back. Alright. And it's time to do some fun stuff. Well, sort of. I actually really like this language for explaining this. So I'm going to move it to the top of the file. Excuse me. That is insane. How did I just pragma twice? You know what I'm saying? People don't know about it. The pragma twice method. Pragma twice. People don't know about it. People do not know about it. Okay. Okay. All right. So basically, what we're about to do is first we're gonna work on the ledger, and then we're gonna work on an API. Now, as I was taking a break, I did have some concerns. Originally, I wanted some sort of element to sort of like indicate that this is a repeating element and it will just take up all the space over and over again. Now, the issue with that is that text is sort of needs to be like resolved at a certain point. So I'm not sure the best way to do that, but I really don't like the old way that I was doing that, where it's like you lay everything out and then you relay everything out once you know the size of something. As for like dynamic views, like list, like a list view, tree view, whatever. Where you know the height of everything. I don't know how I'm gonna solve that, and that's okay. And then the concern I brought up at the end of the last video, where I was talking about, should layout just be separate and there should be no implicit layout? I'm not going to make a decision on that right now. What I am going to do is aim to clean up this file. So first off, honestly, I'm going to remove all the old stuff. Well, not yet. Not yet, actually. I'm going to do the layout ledger stuff. Okay, so this is sort of like draw where the layout tells me to draw. Okay. Case OP layout ledger X. Basically, this is gonna be very similar. This is literally gonna be like, we're just gonna use I think we should just use the this resolved quad for the ledger. I really think that we should just do that. And then so this ends up being pretty much the same thing. Quad mask right, or sorry, quad mask top, top. Okay. We reset the ledger to this sort of, I honestly hate having comments, but whatever. And also, I don't like that. I want to turn off the structured binding thing, but whatever. I'll figure that out later. Okay. So what needs to happen? Eval layout. We need to basically say eval. Okay. We need to advance these ledgers. So in eval quad, we're pushing the width. Okay. So if the layout direction is right, we never change the y. We only change the x. And so we could say something like layout width. So we could say like if ctx.parent layout quad mask height. Okay, right? If the height is resolved, we only, or no. If the layout's right, we don't change the ledger. The ledger is always going to be in the top. The quad mask width, or no, quad mask left. If that is resolved, then we do something like we do it in here. Because if the width is resolved, this might need to be reversed. If the layout width is resolved, I don't know the cleanest way to do this. Because what's a use case? Like does it matter if the layout width is resolved? As long as, let's just write it outside of this, and then. So what we need for sure is this to be resolved, and this to be resolved. Okay. So if this is resolved and this is resolved, parent layout ctx.parent layout quad dot left plus equals ctx.current quad dot width. Okay. So let's separate these out, because, and maybe we can clear this up later, but the logic is too complex. I'd rather have like a bunch of nested if statements right now, because let's say this is resolved up to a certain point, but then this left is like not resolved. If we can't add to it, then we need to say this is quad mask left. Okay. So are we checking? We're checking this once and twice. Let's say parent layout with resolved, parent layout height resolved. Then, because we're doing this more than once, we can say current quad, what is this, with resolved. Current quad with resolved. Okay. And then we can use that again. Okay, so basically as long as the parent can be edited, we need to check to see if we have a value to add to it. If we don't, then we need to undo that and make sure the parent can't change as well. Okay. Now I'm okay with that, but I'm also wanting to see what I used to do here. Move layout ledger. Okay, so if in the case of right, yeah, because the ledger, where we place the thing, like, it's sort of like why use a layout? Like your layout's gonna assume. I mean, I don't know if this is the best way to do it, but like your layout should assume that you're putting things into the layout using layout ledger X or layout ledger Y. If you say like layout ledger X plus 7, for instance, that to me is sort of like, okay, so now what do we need to do? So now we're not using like a moving ledger. Like now we take the quads left. Okay, fine, except what happens when we want to have something that's like absolutely positioned inside of a layout? Then, we have ledger, boom. It just brings it right back if you did something like that. So again, this is like one of these design decisions where it's like there's not really a right answer in my opinion. It's just like, how do you see this thing being used? And like for me, I mean, it's rare that I want to lay something out like if I have like a list of things, I don't want one of those things to be further down than the rest, right? Like you don't see that in UIs. Like you don't see sort of like random spacing or just sort of arbitrary spacing. So yeah, I'm thinking just leave it. I mean, it's not. It's not like. I don't know. I mean, that's how it was working. Like you can see here, like it's literally just like using the previous ledger. I don't again like. Oh, because these are expressions, so I can't do like plus equals. I didn't override that. But and the whole expression class is going to be done with. We don't need that. So we have left, and then with plus equals. Man, I hope what I'm doing is faster. I really do. I think it is. Like I truly think it is. But I guess I mean, we won't see, really. We won't see. I'm committing to this design. I don't really want to maintain like two constraint solvers. Like, yeah. Okay. All right. Then yeah. Let's just say left plus equals that. And maybe we add some spacing later. I mean, we will add some spacing later. If it moves to the right. If it moves down, we want quad mask top, height, don't know why I would assume that it's a different, whatever. Current quad height resolved. And then this is just current quad width resolved, and this is current quad height resolved. Okay, so the only explicit test is this. But I'm not gonna. I mean, for style, it's like you like maybe add it to here, but I don't know. I'm kind of just like over it. Okay. That makes sense. Now, okay, so let's go back to our test. And let's say we have, where's child one? Child one, width, height. So the left is going to be OP ledger X. Get rid of that float. Layout ledger Y. And then we're going to do it again. Layout ledger X. Layout ledger Y. And then we're going to stop here because, yeah. All right, let's hope it doesn't crash. If it doesn't crash, that's good. Okay, it didn't crash. All right, so our first thing should be at 5, 10, 50, 60, right, because we're going down. $60 because we're 10 from the top plus 50, so our ledger should be down at 60. Now, that's our layout. This is our first thing, so our left and our top are incorrect. And our left and our top are incorrect. Okay, so it's not actually getting... So the ledger's updating. But we can't have, like, are we ever hitting this? No. Parent. 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 And parent. Yeah. Okay, that should do it. You see, I'm faster than the debugger. That's a problem. All right, 510, we're starting at the beginning. That's our layout. 530, yep, we're going down. Okay, that looks good. And then if we change this to right, contents height. Oh, wait, where do we specify the layout? Oh, right down here. Right. Ugh. Got a work email. It's like you ask. I mean, you ever send an email and it's just like, I need to like know something, or I need to have something like in writing, and like it's just going right. You know what I mean? It's just going right over the other person's head. It's like they're making no effort to understand what you're saying. They're like, oh, I said this. I already said it. It's like, okay. I mean, maybe it's me, right? You know what I mean? But I don't know. Okay. So far, so good. So far, so good. So far, so good. Um, test failed, but who cares? What? Okay, why would it zoom in? Because I got schmutz on my thing. Okay. Okay. We have our test. Our layout is sort of working. All right, let's get rid of all this code because it's in a different file. We don't know if something has children or not. So but most things won't have children. We could always like we could always set a flag. I mean, okay. Let's not worry about margin and spacing for now. Let's figure out this API. We figured this out. Did I spell layout wrong? What the hell? Okay. I'm actually really proud of this. We can actually just for the stack frame just have layout info, layout, config, and then fix that. And then config. I mean, this looks pretty good to me. I kind of want to keep all this stuff here. We don't need IO stream. We don't need constraint buffer. Okay. We don't need this. I'm actually really excited about this. Okay. Now. Where's V3? Okay. Just close. Okay. So we need something like given a buffer, we need to be able to say let's say something like this. Auto write element buffer, let's just call it ln buffer, and what this is going to do is we're going to say ln buffer dot write, oh wait, ln buffer dot writer dot write and then stood unt depth const. Okay, so we need type and then depth, and we may even be able to automate the depth thing. like if we kind of turn this into like some state machine where it's like move forward, move backward. But I mean, we're gonna have to keep track of the depth. This might be a useful API to have underneath it that just like is not so reliant on the state machine, that we can like actually test it. That's probably the way to go for now. Just like this is very easy to turn into an API because we can see all the sort of like, I mean, it looks like a lot, but it's like, okay, we can see the different steps. We can see how we would do something like this. So like we have like, okay, so first we like write an element. Then we would say something like write quad field. And we say something like buffer, lm buffer, and then we take a const quad field, and then what we need to do is we take an expression. And this is where the state machine sort of comes in. So maybe because we do, yeah, let's do lm let's do that. And then this will have a reference to an lm buffer. And then it will also have some other things. So we can have something like stood uint depth. That will be 0 by default. We should this should be like only initialized with that. Okay, so we shouldn't have to specify depth. And what we should do is element buffer writer. Can I just be const? Yeah, probably. Okay. Then buffer writer. We could say something like See, this is kind of interesting, right? Oh, okay. So, let's try it like this. We could say write quad field writer.lm. Oh wait, no, we take a const element buffer writer. We say writer dot okay, so we write the quad field. Then for the expression, this is where it's sort of like I really want to be able to write something like ideally what we do there's got to be like some sort of like intermediate expression thing. So like how can we do that? Okay, well, inline auto operator plus, let's take a const float, left hand side, and a const op right hand side. See, this is where it's sort of like we could have a struct expr, and we can say like this is like where we kind of need what we already had, where I think what we need to do, because what do we return from this? We return like we need to maintain that these two things are being added together. I mean, do we do like a void? If we have something like, what if we, I mean, this is gonna be stupid. Inline auto writer or shared writer equals element buffer writer. Make that a pointer. Make that have to be initialized at some point. Okay. I don't love this so far. Let's see what happens. If it's plus, then we say writer, or we say shared writer dot ln buffer dot writer dot write float. Then we write the actual float. Then we write right hand side. Then we write add. And then honestly, we could have a special one saying result. So return op result. Okay. Why is this genius? Why am I a genius? Okay, well, I'll tell you. So, or maybe this ends up being a pointer. Either way, we have something like this. That means that, like, let's say inline auto operator multiply. Const op left hand side, const op right hand side. Or honestly, maybe we don't have this. Maybe we have like a separate type, like struct result. And we just call it that. We return a result, return the empty result. Because then we could say, like, does this just balloon what we have to do? Do we have to write 3 overloads? Like let's say just for operator plus. Then we have const OP left hand side, const float right hand side. And we're gonna do a lot of the same stuff. We're just gonna have left hand side op float, right hand side add. If it's inline auto operator plus const OP left hand side right hand side, we're gonna do the same. We're just gonna do that. And then, okay, so that's all of the combinations there. Now the issue is we need to also account for 4 more, right? We need to do const OP left hand side, const, or we need to start with, let's start with result left hand side, const OP right hand side. We're gonna just right hand side and then add. And then return left hand side. And then we might not. No, we probably do, because if we have something in parentheses on the right, we're also going to need left hand side, right hand side. Right? Shoot, did I mess this up? Because if we say hold on. I might have not thought this all the way through. So if we have like 5 plus 6 times 7, well, I don't even need the parentheses. 6 times 7 is still, this gets processed first. So this ends up like 6, 7 times 5 plus. But what if it's this? Versus 6 times 7 minus 5, which is a different thing, which is still 6, 7 times 5 minus. Okay, wait, I don't know. Let me go to chat. This versus this in reverse Polish notation. The operator becomes after. Yes, I know that. Fuck face. Oh. Oh. Okay, so my math, some of my math is wrong, because really we don't, I think I was right before. The arg buffer should probably be longer, first of all. Let's give arg buffer 16. That's probably fine, right? Okay. What is missing here? Oh. Okay. Aware. Hold on, let's think about this. Because C++ is gonna evaluate the multiplication. So if it's 5, so 6 times 7 gets done first. So it's 6, 7 multiply 5 minus. I don't think that would be right. I think 5 minus 6 times yeah, that would end up being the 5 is pushed on, then the 6, 7, and then that consolidates into 1, and then you get subtraction. This one is like you get 6, 7 minus 5. Okay. Bear with me. If you know this shit, then I feel like I did, but again, like I've only implemented it sort of the AST way, and this is a little bit different. So okay, so the arg buffer. This is sort of interesting, right? So let's think about this. So let's say we get arg buffer Well, hold on. First let's make sure we can create this. So if we say plus Oh man. Okay. Hold on. Let's say auto res equals let's just try to do this first one. Let's say float minus op width times op height. Okay, so there's no operand for op times op. We can do that. Op multiply. Now there's no operand for float and results. Float. Okay, float and result. No, I won't forget. No, I won't forget you. No, I won't forget you. We are humans, we all cry. Oh man. Okay. Man, I was all jacked up to do this. This is still way better because if we can build this in place, I mean, that's gonna be tough. Like, good. Okay. So then, so first we call this. Boom. Then we call this. Now that's sort of a problem. Do we need something intermediate? Do we need an intermediate thing? We might, because shoot, I didn't want to do it this way. Five. Because if it always is going to respect the order of the operations, then it's going to say boom, boom. Then how do we put the 5 first? We're not going to hit, like, if we do something like this, right? Multiply, subtract. I mean, it's going to crash, but whatever. The first thing that gets called, okay, what? What? Jesus Christ, what have I done? Something with that? I hate this. I hate this. I hate this shit. Why? Like, that's sort of the annoying thing. I mean, it's good to catch these mistakes, but it's just like so annoying to like deal with this stuff. Okay, now I can add all this back. And let's see which function gets called first. It's probably the multiplication function, and what's gonna crash before? I guess, yeah, so the multiplication function gets called, so we have no clue. So how do we go from this do we have to do, like, do we have to have an AST? I honestly think we do. I think we do. I honestly think we do. Can we do it without some sort of like helper type? Is it that bad to have a helper type? I mean, we're gonna have a ton of overloads if we don't. So if we say something like, we know this times this, I don't want to use the expression thing I already have. It's so messy. I want to say like expression. Doing expression plus expression. And then we traverse the tree. I'm just like, I don't have the patience to, like, just give me a okay. I'm ashamed I'm putting this on the internet, but it's just like, I just want to figure this out. And that's fine. What? I hate this stupid. Let's just do that. Let's just do. Expression. Say the expression tree is just a stood vector of expression tree is going to be a come on, lock in. Enough of this. All right, the stood. I mean, it's basically going to be like a stood variant of either op or float. And then like each node, is gonna end up being probably could just be like stood UN16T index it could be index and then it could be like offset and then it could be is op false, or let's just say is float false. Okay, so a node is not big. So a node is not very big. It just has an offset and something that says whether it's a float or not. Then writer UN8T div. What am I looking at? Okay. Excuse me. Oh, I thought this was gonna be more fun. We have to make these like little micro asts, but that's fine because we're not making like a huge tree structure. It's still gonna be like close enough memory that I'm not gonna freak out about it. Okay, so like the expression node, and then we need to keep track of the children. Fuck it. Stood vector oh wait, no. That's not gonna work. Is it? I don't know. Let's see about this. This basically needs to create multiple node, create two children, left hand side and right side. So tree, let's say like inline auto shared expression tree equals expression tree shared expression tree dot I mean, really what we do is we data dot in place back left hand side, data dot in place back right hand, or shared expression tree dot data dot in place back multiply. Okay. So now we need to say children end up being so the next two nodes. All right, so really what we need to do is we have an expression because we need to keep track of children. We need a way to add children. We need to be able to say, and I don't know why I'm blanking on this. I literally wrote it and I'm so stubborn that I'm not like actually gonna go Man, I'm tired, but I gotta keep going. I mean, it's been an hour. I'll see if I could put another hour or two in. Oh. Once I finish this, I'll stop it and then restart it, and then it'll be like a more entertaining one. I mean, I don't give a shit about entertaining. Like, I do not care if you guys are entertained, to be honest. You guys, it's nobody that's watching these. I'm not even complaining. I'm literally doing this for accountability and documentation. It's for myself and Mac and Charlie. People don't know about that one. Okay. Why am I blanking on this? Okay. So I need to create. I need children. I need this. Well, I basically create a node and then add. This is the data. Well, see, a node is either going to contain the data itself, or point out to some data buffer. I think it's probably fine to contain the data itself. Well, no. We could say we know this is going here. Then we could say we know what type it is, so we can parse it. Then we have stood array that's what it is. Okay. Okay. See, this is not good, but it's also not bad because it's not like we're like writing a huge tree. So we have expression node. These are indexes to other nodes, and the nodes get indexes to the data. Call it that, just to not be confused. Okay. So what does in place back give us back? Does it give us an iterator? No, it just okay. So we can say shared expression tree dot nodes dot in place back obviously this dot size is float is false, and then children would be the next two. All right, why is it complaining? Because what do you mean undeclared identifier? It's right there. Nodes dot in place back. Whatever, let's just make this a size T. Stood array, and then what was the type? Stood size T. Okay. Well, what this could do is we could have something like okay. Here's what we can do. All right, in the fourth quarter, going crazy, locked in, locked the fuck in. All right. Let's say this is a function, and let's say this is auto insert. Bool. Okay, so we got stood variant op float data. Insert the value. Okay. Val dot probably don't even need this. I'm just gonna put false for now, but we might not even need it. And then children. Okay. So we have our index to data that works. We have our children. There's no dynamic memory. There's no fragmentation. Okay. Worst comes to worst, we don't use all fields. We could even do this a little bit differently, but shared expression tree dot insert. We really want to insert left hand side, and that's gonna fail because we did not write an overload for no children. Multiply, and then can literally just do that and that. And that way the last thing that we add I guess it actually doesn't matter which in what order these are executed as long as left hand side is on the left. Okay. Okay, then insert subtract, and then we take the previous root, which is going to be that. Well, no, it's not going to be the node. It's, yeah. That's the index to the last node. And then we want to say, we want it to be like that. Okay, so if we run this test, we get, well, the result's going to be empty, which is fine, but let's see what's up with this tree. Okay. We have 5 nodes. That makes sense. The first node, this is going to be root. 4 is an op, it's subtract. Its children are 3 and 3. Okay. Its children are insert should return nodes.size -1. Oh. So let's do something like this. Return nodes.size -1. All right. Okay, so the children should be 3 and 2. Okay, so 3 is first. So 3 is 5. 2 is honestly, let's do this. We don't actually need this data buffer. This could literally just be Oh man, I'm sorry. I had to go. I had to go silent because I'm just trying to figure this out. Um. Actually, don't need that. Okay. All right. Shared expression tree. Okay. Subtract 3 minus 2. So it should be 5 minus 5. Should be all empty. Minus. Okay, multiply. So that should have some children. Height and width. Okay. All right. Chat. Can you to insert functions into one templated insert function that fills the array with 1, 2, or 3 with 0, 1, 2, or 3 children. Let's see if it one-shots it. Yes. Oh, thank you. Thank you. Okay, wait. Now, if everything has 3 size t's, wouldn't it be better to just give everything 2 size t's and say child index num children? That way we could support any number of children. Be a little bit more spread out. I think let's do that. I mean, we're already here, right? Stood vector, stood size t children. And a node instead of has that has stood size t children index size t children count. Okay, so that way everything has 2 instead of 3 size t's. I guess that's a little better. But this allows for like any amount of children. I think this is a little bit better. I can't do like the loop folding stuff. Yo chat, can you actually do it so is still variadic, but pushes each child onto the children array and sets the start index and the num children on expression node. Alright. Oh, that's actually a nicer layout. Better. Yeah, I know, because I came up with the dick fuck. Sorry, that was aggressive. Ooh. Why can't I just take a size? What? Yeah, I don't give a shit about restricting the type. I really don't. I don't use this pointers. Fuck static assert. Does this look like I wrote the code? Yeah. Let's run it again. Cause honestly, yeah, I'm like, fuck AI in some senses, but dude, sometimes just like folding syntax or whatever, like it just like really messes with me. I just don't have it in me right now to like go through and like relearn this. Okay. Children index is, wait. Subtract. Children index is 0, 1, 2. And the count is 2. So 0, 1. Okay, so 3 minus 2. So 3 is 5. No children. Multiply 0 and 1. Okay. All right. That's good. I like that. Okay. So, here's what we want. We can only maintain one expression at any given time. We can only maintain one expression at any given time. We're just gonna make it, it's just gonna be what it is, because none of these things have any sort of like state. So we need like the shared sort of expression tree. I'm just gonna do that. That looks sexy, right? That looks sexy. Okay. Just to test this out, we say con and then const result. If it is result, we are going to say we're going to consume the expression. We're going to consume the AST and put it into the we're going to consume the AST and put it into the buffer. So we know what the root is. So we say let's just put this in a loop for now. We'll figure out the conditions. So we say while true. So we know what root is. Const auto node equals, let's say auto node equals ast.nodes dot ast.root. Okay, node children count. So we need to we say if it's an op, switch. All right, so we say if node dot value dot holds float, then we say writer dot lm buffer dot write float, and then the value. Okay. Else switch stood get op node value. Okay. Case add, case op subtract, case multiply, case divide, case op max, case op clamp. These all get pushed. So otherwise, we just write it as it comes up. We just write node value break. Okay. And then we say ast dot nodes dot clear, ast dot children dot clear. Let's say it's add. We want to say, well, we actually don't care what it is. All of these things are going to have the same behavior. We want to say, well, let's see. If we go, if the first node is subtract, right? We hit subtract. We push that onto some stack. We say, here is we push it onto some stack and we say, okay, we're gonna go subtract and then a negative value. So we go 5 only once we get back to that node. Because if we go I don't like this. I hate trees. I mean, it's just like it's really easy to like do this really naively, and I already did that. You know what I mean? So I don't want to do it again. Like I want to think about it, because you want this to be like as linear and contiguous of an operation as possible. I hate like when you drink from an iced cup and then shit just like falls out. That's so annoying. Man, oh man. This one's a doozy. This one is a doozy. That's cool. We'll figure it out. This is gonna be a way better expression. This is way better than before. Like way better. I think. I don't know, but I think. My instinct is that it's better. Okay. It's cleaner. It's cleaner for sure. Okay. It's cleaner and simpler. Okay, so to traverse an AST, I'm getting another opinion. Chill. So to traverse an AST, do I and emit a Polish RPN? What's the best way to do that? Am I being stupid? Am I dumb? Am I dumb? Am I dumb? I might be dumb. I might be an idiot person. I might be like an idiot man. Jesus Christ. Okay. Um. Parse node. I mean, we could literally do it like this. I mean, but we know this can't have it. Okay. I am like, I'm really ashamed. I think I've just been coding for too long, which doesn't even feel right. It's only been a few hours. Like, that's not. Let's say I equals node dot children index, and I is less than node dot children index. I guess we could just do one of these, and then say, writer, and then ast.nodes dot node dot children index plus I. Boom. I guess that could be const. Okay. Write expression node. Okay. Okay. Now we're talking. This feels like it could work. And then we could say, right, we could have an overload for, let's say, float. And we could say, okay. So we have a way to, so next, so we get our type here, right? Now we need this thing. And we need sort of like a write expression function. So inline auto write expr const element buffer writer const result this should really be like that. But then we also have this idea, right? So we have writer dot ln buffer, which I guess is a pointer now. Somehow that happened. Writer dot ln buffer dot writer. Oh wait. So expression size and then we can say writer dot ln buffer dot. Do we actually, is there literally, is that the only reason to have some state? Oh no, we wanted depth. ledger do? Oh. Writer dot ln buffer dot data dot size. Okay. Okay. We write a placeholder size and keep a pointer to it so we can update once the expression is written. Okay. Write expression node. Then we can say that. Writer.lnbuffer.writer.data.size minus ledger. Oh, okay. And then we clear this. And then we write quad field, and we could say writer dot write expression writer. Why are we searching everywhere? Why are we searching? Sorry, I got hot. Right expression. We should still do that. What's same as versus is same? I hate the STL sometimes. Okay. Is same as expr. If t is the same as expr. Okay. All right, so we have right element. So we could do something like this. We could say right element right element, writer, element, type, box. Okay. Right quad field is writer, and then quad field width, and then OP contents width. Am I drawing for that? Whatever, it's happening. Why? Can I just take that? And then take that? Okay. Okay. Right quad field width, right field height. Left is 5.f. Top is 10. Damn, now like this is so predictable. I don't know why. Oh, I guess this should be inline. Okay, so we have our parent. Then we need like inline auto begin children. And then we can say begin children. Okay. Now we can say child 1 is going to be a box, right element, writer element type box, right quad field. The width is going to be, what do we say, 60 by 20, 60 by 20, and then left is going to be OP layout ledger X, layout ledger Y. Then the next one was like 50 by 30. Okay. Let's see. Is it gonna work? I didn't test, I just check the out buffer. Okay. Yep, ledger makes sense, right? It goes, yeah, we have a layout that goes down, so 20 plus 30, so it should be 50, and then the widest should be 60. That's a layout one. This is, or this is a real one, 60 by 20, 510, and then 530 should be 50 and 30. And then this one should be nothing, and then this one should be empty. Come on, bro. See, this is the type of shit that, like, okay, now we have like an intermediate API. Okay, so the cool thing that we can do here, okay, now that we have this, we can write like we can expand this. We can expand this to support text, right? But we have an API to build our element tree in place. Do you know how huge that is? That's huge. Okay, that's really big. That's really important. Oh, okay. So where do we go from here? Well, this is sort of like, line by line syntax. Really what we probably want is from here, we want to be able to say like box dot, we want to be able to use our like other syntax, our declarative syntax. We want it to be declarative. We want it to be all done in one call. So I guess that's next. All right, let's go. Good shit. Come on. That's huge. Man, we're locked in. That's 2 hours. I'm about to put in some more. But I gotta take a quick break. Go for a quick walk. Get some water. You know the vibes. Come on, that's huge. That's a big win for today. We've really been locked in today. Good shit, boys. Let's go.